The center is at h comma k, and everything else is basically the same. So the only thing that's happened is we've had a horizontal shift and a vertical shift. So if you remember anything from the section on parabolas, when we went from our parabola set with the vertex at 0, 0 to the parabola that was shifted, it's the same exact thing that ends up happening as far as our equation. And simply we're subtracting h from x and k from y. So our equation becomes x minus h squared over a plus y minus k squared. And that's a squared over b squared, and that equals 1. Our vertices, okay, are at h plus minus a, comma k. The endpoints of our minor axis are at h, comma k plus or minus b, and our foci are at h plus or minus c, comma k. If you will, essentially replace any zeros with the h and the k's, and all this ends up happening. And so if you think about where we had, well, our vertices on the other one was plus or minus a, you can think that's 0 plus or minus a. Okay, but this is really the general form you want to kind of think about. And so go from there. So I'm going to kind of draw this out here. H, K. Kind of do this just to kind of help me get my shape a little better. Try and really, didn't even want to recognize that. That's pretty cheap. Okay, we're going to get one that's going to work. There we go. That's good enough. So, again, this point here, h comma k. Now this point here is h comma k plus c. That focus. This is h comma k minus c. H plus b comma k. H minus b comma k. H comma k minus a, and h comma k plus a. It's super not helpful when it's all these letters and everything is just kind of randomly assigned here and stuff like that, but it's still kind of nice to have that written down just so you can kind of see it. Again, our equation is very simple. X minus h squared. Now, since this is a vertical major axis, that means the major axis is kind of on a vertical line, which is the same as y. So that's going to have the larger of the two values. So that means the denominator here is going to be b squared plus y minus k squared, h squared, and that equals 1. Okay. Our vertices are h comma k plus or minus a, h plus or minus b comma k for the endpoints of our minor axis, and h comma k plus or minus c for our foci. Now for both of these, it still holds true that a is greater than b is greater than 0. Okay, and again, what's really nice is our foci, our c value, is still c squared equals a squared minus b squared, and c is greater than 0. So what's really kind of a big takeaway here is whichever variable, x or y, has the larger denominator, that is the direction of the major axis. Okay, so if it's the x has the larger denominator, the x-axis is horizontal, so that'll have a horizontal major axis. If the y value has the larger denominator, the y-axis is vertical, so that'll have a vertical major axis. So that's kind of a good thing to remember to kind of keep track, and then honestly just refer back to these little quick hit formulas right here, okay? Don't necessarily try and go rogue and be like, I'm going to memorize all of this, because that's when you just flip each and every one of these, and I'm looking at your test going, oh yeah, I see you flipped all of these, and I'm going to have to dock you points. So just make sure you come and look at this, have this available to you on your quick sheet, and make sure that happens. So here we are told, find the vertices, foci, and endpoints of the minor axis, then give a rough sketch of 3x squared plus 2y squared equals 6. Now, you may be going like, how is that a parabola? Like these other ones, the formula was like divided by things and this is multiplied by things. But what helps us here is that 6. Because remember, what did all of these equations always equal? They always equaled 1. And so what I want to do here is I want to divide by 6. And what ends up happening is I end up with 3x squared over 6 plus 2y squared over 6 equals 1. And now the reason I can split that, right, is the same reason kind of adding fractions, the same works. Now I can simplify both of these and I end up with x squared over 2 plus y squared over 3 equals 1. Now, let me ask you this. Is this a horizontal or vertical major axis? Right? And what we have to think about is which variable has the larger denominator. You can see here clearly it's y. Y has the larger denominator because 3 is bigger than 2. So this is a vertical major axis. Vertical major axis. Now we can also see here there's no minus h or minus k. We just have x squared and y squared. So what's really nice about this is not being shifted away from 0. So it makes it easy to find all of our centers and things of that nature. Now, here's something that gets really tricky is a lot of times people will be like, cool, so A is 3, B is 2. But that's wrong. And let's go back and look at our formula and see why is that wrong. Because our formula, the A and B values are squared, okay? So when we're looking at this problem and we see, hey, I have x squared over 2 plus y squared over 3, that means that these are actually the A squared and B squared values. So let's really clearly for ourselves define what is A and what is B. Now remember, A is the bigger of the two. So A is the denominator under the y term. And since the denominator is 3, which is really A squared, A is the square root of 3. And B, so the denominator of the x term is 2, which is really B squared. So that means B is the square root of 2. So now there's another thing we want to find really quick before we do anything else, and that's our C value. So we know that C squared is equal to A squared minus B squared. Okay. Well, in this case, A is root 3, B is root 2. Square both of those, and we get 3 and 2. So very simply, this is 3 minus 2. So C squared equals 1, which means C equals 1. So we know our A, we know our B, we know our C. That allows us to very quickly and easily identify our vertices, foci, and endpoints. Okay. And so the center, which isn't something we're asked for, but it's kind of a nice thing to kind of think about. Center is 0, 0. Okay, then our vertices are 0 plus or minus root 3. All right, now if you had to create a list, say like for the online homework, right, you would give one point would be 0 comma square root of 3, and then your other point would be 0 comma negative square root of 3, or vice versa, depending on how the question is formatted, right? A lot of the times it may say give the smaller of the two, or the the one with the smaller value first, so you do the negative root 3 first. So there's our vertices. Next, our foci. Remember, those are going to be along the same axis of the major axis, so the same as our vertices. And those are just going to be 0 plus or minus C. So since our C is 1, this is just 0 plus or minus 1. And lastly, the endpoints. And you could go through and say the endpoints of the minor axis. I'm just going to say endpoints because I just want to skip some steps. And so that is just going to be a lovely plus or minus root 2, 0. So now I wanted us to sketch a graph. So we don't want to get too crazy about this. But we are having a vertical major axis, so we are talking tall and skinny. Okay. Here's our C's. That's at -1. That's at 1. This point right here is root 2. This is negative root 2, negative root 3, root 3. Right? And because this is centered at 0, 0, I can kind of do it as like that, and that is sufficient enough labeling. If this wasn't at 0, 0, I would want to actually give the ordered pair for each of these points that I'm labeling on here, just to make sure that we are very obvious and clear. Find the standard form and sketch the ellipse for 4x squared minus 16x plus 9y squared plus 54y equals negative 61. There's a lot going on here that we got to unpack. Okay. First thing we have to do is really just build up your disdain for this kind of problem. I'm just kidding. This is a fun problem. If you've done completing the square, this is actually a really fun application of that. If you have not done completing the square, we're going to do that today. I don't want to go into too much detail of it, basically, because I'm not going to expect you to do this. I'm going to give you problems that are going to be already into the nice and simplified form, because this is just some algebra manipulation, which is a Math 111 type problem, not a Math 112 problem. So what I'm going to do is I'm going to say bippity boppity boo, some magical math magic happens, and I get the lovely form x minus 2 squared over 9 plus y minus negative 3 squared over 4 equals 1. All right, bippity boppity magic. Those are equivalent. If you do not believe me, feel free to do it yourself. Start by isolating kind of in your own way, not necessarily actually isolating themselves like on the left or right side of the equation, the x terms and the y terms, and you're going to kind of almost physically separate them. So you'd have 4x squared minus 16x. Leave yourself a good space. 9y squared plus 54y. Leave yourself a good space equals negative 61. And what you're doing in that space is you're going to factor out the leading term there, leading coefficient. So for the x's, you'd factor out a 4 from those two terms. For the y's, you'd factor out a 9 from those two terms. Then you perform completing the square, and what you're left with, once you have that, it'll condense down into x minus 2 squared and y plus 3 squared, or y minus negative 3. And then divide by the negative 61, simplify what you can, and you will end up with a, well, you won't divide by negative 61. When you complete the square, that changes to 36. Divide by 36. You'll end up where we are. So this is our formula. So is this going to be a horizontal or vertical major axis? Well, because the denominator of the x term is larger, the x-axis is horizontal. This is a horizontal major axis. Okay. Now we need to find a few things, but first, the center. This is going to help us because we're going to sketch a graph. So our center will be, since this is definitely not at 0, 0, right? We've got some stuff going on with these x's and y's. Remember the formula, let's just jot that down to help refresh ourselves, is x minus h squared over a squared, since we're dealing with horizontal major axis, and then y minus k squared over b squared equals 1. So our center here, so it's minus h, so since it's x minus 2, our center is going to be at 2, comma, and then y minus negative 3, so then it's 2, negative 3. So some good things to identify here is obviously our a's, b's, and c's like we did on the last round, but also our h and k value. Those are good to identify. So h is 2, k is negative 3, our a, our b. Now this is another nice problem here because remember, again, the denominator there of these two terms are both the a squared and then b squared. But this 9 and 4 are not squared, so we have to square root them. But luckily, those are nice square roots. So we get that a is 3, b is 2. So c is equal to a squared minus b squared, sorry, c squared. Okay. And so c is equal to the square root 9 minus 4 square root of 5. Right. So now we can use this information to find our vertices, our foci, and the endpoints of our minor axis by simply following the formula that we have from our general form of a shifted ellipse. And so if you go back and look at that, you will see that our vertices are going to be at the point 2 plus or minus 3, comma, negative 3, that are, and so those are 5, negative 3, and negative 1, negative 3. Our foci are very simply a 2 plus or minus square root of 5. So I'm just going to write this 2 plus square root of 5, negative 3, 2 minus the square root of 5, negative 3. I didn't like that dot. Our vertices, our foci, and the endpoints are going to be 2 plus or minus, 2 comma negative 3 plus or minus 2. So that's 2 comma negative 5 and 2 comma negative 1. Okay, so there are our lovely points. Now to get a nice sketch. So our center, remember, is at the point 2, negative 3. So that's roughly about here. Okay. It's really nice to not just like throw the, be like, draw an ellipse, and be like, here we go. There's my rough sketch. That was the best ellipse I've drawn all night. Man, I'm jealous of myself. Well, that turned a really garbage ellipse, automatically shifted into a great one. Okay, sorry about that. So we have a horizontal major axis, right? That's what we figured out here. Okay, and we have vertices of 5, negative 3, and negative 1, negative 3. So negative 1, negative 3. That's 2, 3, 4, 5. Okay. And then we have endpoints of our minor axis of 2, negative 1, and 2, negative 5. So that gives us enough that we can kind of get a good sketch of this now. Football-y looking thing. Okay. And now we can drop in our 2 different foci. Now, it's important that you actually do grab your calculator and look at what is 2 minus square root of 5 and what is 2 plus square root of 5. Because if 2 minus square root of 5 is 0.3, the foci is here. If it's negative 0.3, it's here. Those are 2 big differences, right? The side of the y-axis that it's on makes a difference. So we want to get that a little more accurate, and it actually is a negative value, so got 1 foci here, and then our other one is roughly about here. Okay. And there we have it. There is our lovely little guy. And you could go through and label all of these points with what we found out, what we've created them based off of, but this is pretty sufficient. Okay. Now, there's one more problem on here, but it's getting late. I am posting this too late in the day for this. I posted this beyond when I said I would. So for those of you in fall 2020, I apologize. For the rest of you in the later terms, it's not late. It's on time. So have a great day. But either way, we all like to see it when I write this word in big red. Skip. Because again, this isn't how we would solve this kind of problem. It's kind of annoying and tedious. So with that, guys, have a great time doing this homework. It's pretty short, pretty simple. And that's it. See you later.